Greetings. Derivative of x square is twice x. So mathematically we know this very well, right? And also we can prove this mathematically. There is no big deal in this. But if someone asks you, can you show this graphically? Yeah. Can we visualize this differentiation of x square, that is twice the x? So now what could be idea for this? For example, let's take say y is equal to f of x. Say y equal to x square is our actual function. Okay, so let me go for another color. So y is equal to x square is this. All right, so now what we do is we do this. Let us take y is equal to x square as a surface. Okay, so see, let me take a square. This is a square. Okay, now this square is of side x each. Okay, so anywhere you go you have x now. So now what you do, let us try to increment this. Let's try to increment this x by a tiny amount, that is say dx. Say dx is very small, say dx is infinitesimally small, or it's tending to 0. It's very small quantity. Let's try to increase this x by some small amount dx. Okay, so this is what. So we have increased our x by small amount or a tiny amount, and this tiny increment is, say, this is what your dx. And not only here, also we have to increase here, right? So the same tiny amount we have to increase here as well. So now this part is dx. So now what happens is that if we increase this x by a tiny amount dx, the area of the square will increase by approximately 2x dx. How? Let's try to segregate this one. For example, let's try to segregate this. Now what is this portion here? So if I take this portion out, if I take it out, now what do I have? I have something like this. So I have a rectangle. Now this side is x and this is dx. Now what must be area of this rectangle? The area of this rectangle is, so let me take its area. So the area of this rectangle is equal to x times dx. Okay, similarly, what is this area? So this area is also x times dx, because this is x, right? So this is x and this side is dx. So area is x dx. Now what happens is this. Now the increase in area of the square. So let's write like this. The increase in area of the square is not exactly equal to the area of these two red areas. Yeah, because what happened here, this is what happened. You see this side, this small portion left here, you see we did not include this small portion here. Yeah, now if you take the small portion is, this is what side dx, and this is also side dx. Now we know dx is a very small quantity, infinitesimally small. If dx is small, now dx multiplied by dx is the small area, right? The small area. So dx multiplied by dx is very small. It's really it's even smaller than this dx. So therefore we can neglect this one. So at the cost of this small quantity, now we could say the increase in this area of, the increase in this square is now the increase in our area, the increase in the area, let's give a name dy. Okay, so initially we have y, this y is equal to x square. Now because of incrementing x by a tiny amount dx, so now we have a new word, that is a new term, that is dy. Now this dy is what? This dy is nothing but addition of these two areas. So xdx plus xdx, and this is what now? 2 dx, I mean multiplied by x here. Okay, so 2 dx multiplied by x we have is this. Now from this let's come to this side. Now finally what do you have? So dy is equal to 2x dx. Now dy by dx is our derivative, this is equal to 2x. Yeah, simple, right? So differentiation of x square is 2x. This we have proved graphically now. That's it, it's very simple. Now what you do, now you take a parabola, y equal to x square is a parabola, right? This is a quadratic quantity, or it's a parabola. So you go home and try to find its graph, okay, using your differentiation concept. Okay, thank you.